concepts video on quadratic functions. So the general quadratic form looks like f of x is equal to x squared. So this is our quadratic means some kind of squared graph, okay, or squared function, squared power function, where the vertex, let's just define a point here. So vertex is equal to a point where the graph changes direction. And by direction we mean increasing to decreasing or decreasing to increasing. Changes direction. Okay? And I'll just write in here increasing to decreasing or decreasing to increasing. Okay? So basically when we have something like this, so increasing, and that was supposed to be an arrow, increasing to decreasing, so the vertex is right here, okay? Or decreasing to increasing, so decreasing, increasing, so here is the vertex right here where that changes, okay? Okay, so for this problem, we're kind of going to walk through a whole process of what you can do with a quadratic function, okay? And all the forms it can look like. So, it says to write an equation for the quadratic graph below as a transformation of our f of x is equal to x squared graph, and then expand the formula and simplify terms to write an equation in standard polynomial form. So we'll do the second part later, but right now it says express this equation as a transformation of this guy here. So that's our parent graph, so the one that just looks like the following, where we have our normal, like something like this, some kind of U shape, right? Based at the origin, and you go over 1, up 1, over 2, up 4. That whole thing, right? So now we're not looking at that, but what we're doing is going to express this guy, the graph that we see, as a transformation of that, okay? And so the form for the transformation form, so transformation, aka vertex form, it looks like the following, okay? So we're actually going to have f of x is equal to, and then some kind of a times x minus h squared plus k, where vertex is given by the point h comma k, okay? And then a is like our scaling or reflecting factor, okay? So the first thing we have to do is find our vertex from our graph. So vertex means where our graph changes direction. So from here, this is decreasing, and then it changes to increasing right here at this point right there. And that is -2, -3. So -2, -3, that's our vertex, right? So what we can fill in for our equation so far is the h and the k. So a times x minus h, so minus a -2 is the same as +2, right? And then squared. And then we have plus a -3, which is the same thing as saying -3. Okay, so we have this so far, and now we don't know, well, how much is it stretched or anything. So what we can do to figure out this a is just find a point on our graph, because that's what we have to use, right? We just find a point on our graph other than the vertex. So find point other than vertex, of course, other than vertex, and use, well, we can say instead of use, we could just say and plug in to equation to find a. Our scaling factor. Okay, so we'll do that on the next slide. Okay, so let's find a point on our graph. So a good point might be, I don't know, 0, -1. That's on our graph, right? So we could use the point 0, -1. What we're going to do is plug this in for x and this in for our f of 0, so f of x, basically. Okay, so we're just going to say, okay, so -1 is equal to a, that's the thing we want to find, times 0 plus 2 squared minus 3. So if we do that, we just add 3 to both sides, right? So this would be a +2 is equal to a times, and this is going to be a 4, right? So a times 4, or 4a, right? So you just divide by 4 on both sides, divide by 4. So we get a is equal to 1/2, right? And that completes it. Now we have f of x is equal to 1 over 2 times x plus 2, quantity squared, minus a 3. Okay? And that's it. This is our transformation form, or vertex form of our equation here, of our quadratic function. Okay? So now the second part of our question asked us to do some math, basically, and simplify this in order to get it into standard quadratic form, or standard form, right? So let's walk through that on the next slide. So what is standard form? So let me write that. So standard quadratic form, or I could say standard form of a quadratic, because each type of equation has its own standard form, but of a quadratic would look like this. Of a quadratic looks like f of x is equal to ax squared plus bx plus c, where a, b, and c are just constants. They're just numbers. A, b, c are constants. Okay? Okay, so if we look at what we had before for our problem, we had f of x is equal to, we arrived at the equation 1/2 times x plus 2 quantity squared, and then minus 3, right? So in order to get this into this form here, into the standard form, what we have to do first is just FOIL this guy out, right? So just multiply that out. So we would get 1/2 times x squared plus 4x plus 4, and then minus 3, right? And then when you distribute that 1/2 in, we get 1/2 x squared plus a 2x plus a 2 minus 3. So this is ultimately going to be 1/2 x squared and then plus 2 minus a 1. And there it is. See, this is our a, that's our b, and this is our c. So finally we get into the form, which is the standard form of our quadratic. So that would be 1/2 x squared plus 2x and then minus 1. Okay, and that completes the second part of our question. Alright, so from this standard form, let's go a little bit more in detail about what the standard form can give us and why is it beneficial for us to have something in standard form. Or how do we work with it? So if we have our ABC here, basically, you know how HK is our vertex, right? And that's from vertex form or transformation form. So it's really easy to see the vertex when you have something in transformation form. But when we translate it into, when we try to read the vertex from our standard form, it's a little bit trickier. But anyways, we arrive upon the fact that our h, the x-coordinate of our vertex, is given by the following equation. Negative b over 2a. Okay, so whatever, b is just your coefficient of x. Okay, the x to the 1 power, and a is just your coefficient of x squared. Okay, so whatever you do to find your h, that's what you would do here for quadratic. And then k is just whatever the function value is when you plug in your h. So basically f of negative b over 2a, or whatever you get. Okay, so let's do an example of that on the next slide.